So solving a system of equations involves multiple equations with the same variables. We've looked at something called the equal values method. We've looked at solving using substitution, which if you think about it is kind of like the equal values method. And we've also looked at solving systems using elimination. So I'm going to look at two examples here. Of course, the important thing is once I have a solution, it's just verifying that it's correct. I think a lot of good could be done by thinking about, okay, I've solved a system. Now, how do I know what would have to be true if the solution I just got is equal? And the more that you practice those on your own, the more that you just write up a system, find the solution, and then check if the solution works, the more you do that, the stronger you're going to become at solving these. So let's take a look at this example. So I've written the system x is equal to 3y minus 2, and 3x plus 2y is 12. So I think this is a good candidate for substitution because the top equation gives me an expression that's equivalent to x. So this is the same as x. So my strategy here is to rewrite this second equation using the value of x from the top equation. So I'm going to write 3 and then open parens 3y minus 2 close paren plus 2y equals 12. So visually the thing to note is that I have taken this value that is the same, you can see it's the same as x, and I've replaced the x in this second equation with it. So what I've just written down is the second equation, but instead of using x, I used 3y minus 2. Let's go ahead and push that factor of 3 across the parentheses. That's going to become 9y minus 6 plus a 2y equals 12. We're looking at 11y minus 6 is 12. 11y is 18. Therefore, y should be 18/11ths. Okay, now this is not something that I'm incredibly fond of. I don't like these rational numbers when I get these like this, but 11/18ths doesn't reduce, so I'm just going to work with that. So what we're going to do now is we're going to take this value for y and we're going to use it to figure out x. So I'm going to rewrite that initial equation. The original equation said x is equal to 3 times whatever y is minus 2. So instead of writing y, we're going to write what we think y is, 18/11ths, and then minus 2. 3 times 18 is, what is that, 54? 3 times 18 is 54. So I've got x is 54/11ths minus 2. I'm going to look at this number 2 and I'm going to change it to 11ths. Whoops, this is 2 over 1. I'm going to change it to 11ths by multiplying it by the number 1. So you can see if I take the number 2 and multiply it by 11 over 11, I get something that's equivalent to minus 2. So this becomes x is 54/11ths minus 22/11ths. And if I take the 54 and subtract from it 22, I get 32. So x should be equal to 32/11ths. Well, as fabulous as that is, and maybe as compelling as you may or may not think my work is, maybe you saw me make a mistake, I don't know. I'm not satisfied with this answer until I'm sure that it actually does what it's supposed to do. So what I'm going to do is I'm going to write my solution up here as an ordered pair. So I've got 32/11 is x and y is 18/11. And what I want to do now is take those values of x, y and see if it does what the original equation says it should do. So again, all we're doing here is we're plugging in the x and the y that we just found into our original equations and making sure that it makes both of those true. And to aid in that work, I am going to use my TI-84 calculator, the virtual one. And I can see that I need the number 32/11ths and 18/11ths. So One way to get those fractions onto the screen is to go ahead and just enter them as a decimal and then convert to a fraction. So I can take 32 divided by 11, and if I press math, the math button is the upper left, math, and then enter, it converts that to 32 11s. The other way I can do that is to press alpha y equals and grab the fraction template. So now I'm going to type my numerator, which is 18, and my denominator, which is 11. So what's nice is I have both x and y represented as fractions on the display of my calculator. And I'm going to use those values to just check whether or not this behaves the way it's supposed to. So for example, if I take 3 times y and subtract 2, I should get x. So y was 1811, so I'm going to go 3 times. I don't have to type it again, I just go up. And once I'm on that expression or that fraction, I grab it, I press enter, and then subtract 2, and you can see when I press enter it does say 32 11. So indeed using x is 1811, or y rather is 18 11ths, does produce 32 11ths on both sides of that first equation. Now let's take a look at the second equation. That says 3 times x, so I'm going to go 3 times, and x is actually 32 11, so I could just grab this one if I want. There's 3 times 32 11ths plus 2 times, and I'll just go up and grab y 18 11ths, and that should make the left hand side 12. And if it does become 12, that means both the left hand side and the right hand side is 12, and it is. So that means that, yeah, 32 11ths and 18 11ths is my solution, because it does exactly what it's supposed to do. It makes both the left hand and the right hand side of that equation true. So that's an example using substitution. It's often indicated for, like in this case where I had x alone in the top equation, it's easy to sub that in into the second equation, or vice versa. Now let's look at an example that's probably better suited for elimination. And I literally have no idea if this has a nice answer or not. I just made this up. It's possible that they could be parallel lines in which there'd be no solution, or they could be the same line in which there'd be multiple xy pairs that work, or more likely than not, there's just a single solution here. So I'm going to solve this using elimination, and my observation is that the top equation, if it was doubled, right, if I push through a factor of 2 in that top equation, my y's would become opposite of each other. I'd have a 4y in the top equation and a negative 4y in the bottom equation. So that's going to be what I'm going to try. I'm going to go ahead and just show with the red parentheses here and a 2 that what I'm intending to do is take that equation and push across a factor of 2 to each of the terms. On the first term on the left hand side is a 5x, that's going to become 10x. The next term on that side is a 2y, that's going to become plus 4y, and then that's going to equal 2 times 21, which should be 42. Now I'm not changing the second equation at all, I'm just going to rewrite it. That's going to be x minus 4y is equal to the number 8. Now my top equation says that I have equal things, right? 10x plus 4y is 42. My bottom equation says I also have equal things. 8 minus 4y is equal to 8. So what I'm doing mathematically is I'm taking the equal things in the top equation and I'm adding to each side of that the equal things on the bottom equation. Well, when I do that, on the left hand side, when I add these, I end up getting 11x. And on the right hand side, I end up getting the number 50, which is fabulous. I've got another answer that's got 11ths again. So it looks like that means that x is equal to 50 over 11. Now, someone in my class this year pointed this out to me, and it's the first time I've ever was shown this by a student. I really appreciated it. What they said was, hey, if you don't want to deal with that 50 11ths, you can do that again and just instead of manipulating the top equation, manipulate the bottom equation so that you can get rid of things and not have to go through this plugging in fraction, the 50 over 11s, to solve for x. And it's really become my favorite technique. So what I mean by this is now I'm not going to manipulate the top equation. I'm going to take this second equation and I'm going to push through a factor of -5 across that. Now when I do that, and again, this is a completely different take. Uh, I'm starting at the beginning, and this is nice because I don't have ugly fractions during the process. I just get my rational number at the end. So if I push through this negative, well, let's rewrite the top equation because that's not going to change. The top equation is 5x plus 2y equals 21. The bottom equation is going to become minus 5x, and then I've got a -5 times a -4, which would be plus 22y, I think. And then I've got a -5 times an 8, which would be -40. Now, okay, so the original equations, right? There was a statement of equality there, and I changed the second equation to an equivalent equation by pushing a factor of 5 across it. So this system that I have now is equivalent to my original system. What's nice is that this time my x's will eliminate, and when I add these together, I'm going to get 24y equals, and I'm going to go ahead and 40 minus, yes, I'm using my calculator off screen, is 19. So this gives me that y is 19 over 24, and I don't think I could do anything with that because 19's prime. So I'm stuck with 19 over 24. So now here we are, and the question is, that's great. We got this value for x by eliminating the y, and we got this value of y by eliminating the x. Not what I normally do in class. Normally I would plug in my x, but because I got this ugly fraction, 50/11ths, and I didn't want to deal with it, I'm just taking a cue from a student that says, hey, just do it again, and this time instead of eliminating y's, eliminate the x's. My question is this a valid solution? Is this an actual solution? So let me write it a little bit larger here. So we've got 50 over 11, and we're looking at 19 over 24. And we just want to see, does this do what a solution should do? Does it make the equation true? So let's start again by turning on our calculator. And I'm going to clear this screen. And I'm going to go ahead and enter both of these. I'll do 50 divided by 11, and then you can see me just hit math and then frac, enter, and oops, yeah, there's 11 over, or 50 over 11, and then the same thing, 19 divided by 24, and I'm going to just hit, I think I could do this at the same time, math, enter, enter. Yeah, that worked, right? So I've got 19 over 24. So there's my x, there's my y, and I just need to see if this works. So in the first case, 5 of the x's plus 2 of the y's should be 21. So let's take 5 of the x's. So 5 times the x's, there we go, plus 2 of the y's, and that should equal 21. And I've made a mistake. 5x plus 2y is not 21. So this is a point where I really, this is my opportunity, right? This is my opportunity to learn. And it's probably the most rewarding thing that I get to do as a person who thinks about things in this mathematical abstract way, is to try and analyze where perhaps I made a mistake. So I'm going to start by looking at when I multiplied the top equation by 2. That became 10x plus 4y equals 42. I believe that's to be true. 2 times 21 is 42, 2 times 2 is 4, and 2 times 5 is 10. I rewrote the second equation, x minus 4y is 8. When I added those, I did get 11x, and 42 plus 8 is 50, so I got 50 over 11. So I don't see any error that I made in the top equation. Let's look at the second equation. 5 times x is negative 5x. Oh, I can see my error. My error is when I combine, or when I multiply negative 5 times negative 4, I should have gotten positive 20. So this is my error. This should have been the number 20. This is, I know some of you are like, oh my gosh, we made a mistake. No, this is the coolest thing that can happen, because every opportunity I can have to kind of go between what I wrote and what I should have written, it's just amazing. So again, negative 5 times x is negative 5x. Negative 5 times negative 4 should have been positive 20. I wrote 22y. And negative 5 times 8 is negative 40. So that means that this should have been 20y, and that means that y should have been 19 over 20, not 19 over, oh no. Let's not do errors twice in a row. 2, we're combining these. 2y plus 20y is 22y. And when I divide both sides of that by 22, I do get that y is 19/20 seconds, 19 over 22. I'm going to come back in and change this to 22. And I'm going to have a chance again to redeem and see if we can get this right. So let's go back up and grab the original value of x so that it's closer on the screen. There's my x. I'll just enter that. And then my y is 19 over 22, not 24. So 19 divided by 22, math, enter, which is 19 over 22. So 5 times the x, 5 times that top value, got it, enter, plus 2 times y, go grab the y, there it is. This should equal 21. Is it? It is not 21. I've made another error. Somewhere in here I've got another error. I'm still making a mistake. Okay, this is what you call grit, right? This is when it's like all of a sudden it's like, a lot of times you'd be like, oh, it's an impossible problem. There's no way this can be done, right? So, okay, I think I see the other error. Maybe you detected it also. When I combined 21 and negative 40, I should not have gotten 19. I should have gotten negative 19, because if I'm correct, if I've got negative 40 and I add to that 21, or 21 minus 40, this should have been a negative 19. So there is another error that I made. Now, why am I catching these? Only because I'm plugging in my answer and checking it. And I'm not panicked, I'm not stressed. I know that if I do this and I practice like this, when it gets down to me performing, I'm gonna do better. So this is just kind of a process. So now this is gonna be my third try. I'm gonna change this to a negative 19 and hope for the best. So I'm going to go grab the x again. So go up and get the x. There it is. Boom. And then I'm going to grab the opposite of 19 divided by 40. Nope. Let's not do that. 22. By the way, when I entered that opposite, I did use this button down below that's on the next to the period, and above, it's on the same button as ANS. I didn't do subtract 19, I did the opposite of 19. So there's that nice little fraction. Oh, but I didn't turn it into a fraction. Let me do that, math, enter. Okay, so I've got x on the stack, I've got y in the stack, so let's go 5 times, go get that x. It's up a little higher here. There it is. And then plus 2 times, go get that y. Oh, y is right there. Okay, 5 of the x's plus 2 of the y's, and that's funky looking, but that is 2 times negative 19/20 seconds. When I press enter, it says it's an error. It says it's an error because it's seeing that as a negative number, so I can fix this. Let me just grab this. All I have to do is turn this into a multiplication here, so it doesn't see an operation. So I'm going to press second, insert, and hit times. Boom. And I still did not get 21. Oh, because I didn't have the 19 up there. So let me go back up here. Let me get into my numerator. Whoops. I thought that was a third time. I was like, oh no, I can't do this 3 times. I could pull off 2 times, but now it's just like, oh, it's too much. Too much. So let's see. I need to put a negative up there. So I'll just do negative and then 1 and then 9. So I've got 5 times 50 over 11 plus 2 times negative 19 over 22, and it says, oh my goodness, I thought this was impossible. I thought this could never happen, but at least I got one of the two equations to work. And I'm really terrified to check the second equation, but it should be the case that an x minus 4y should be 8, and we got to check this, right? So I'm going to come up here and I'm going to be courageous. There's my x. No, get up here. There's my x. And I'm going to subtract 4 times. I think that's the important thing is I have to hit the times. Now go get that y. Make sure you get the right y. The y that's got the, that's it, negative 19 over 22. So I've got an x minus 4 times y. Please be 8. Oh, there we go. There we go. So probably longer than we signed up for, but honestly, if you could let yourself do this just once in a while, right? It doesn't have to be an everyday thing, but the more that you get into this quote unquote batting cage and you swing and you hit the baseball, right? The stronger you get, the more confident you get, and the better you are at finding errors when you make it, because eventually everyone makes errors, right? I know. Um, I'll tell myself this, and family members will point out, you make mistakes, and like, oh yeah, I do make mistakes, and the best thing you could do when you make a mistake is to try and see where you were at that was wrong, and then try to avoid that. And you can see it was two arithmetic errors, right? One of them was positive 21 minus 40 is negative 19, and the other error was negative 5 times negative 4 should have been positive 20, and I wrote positive 22. All right, so that's a look at solving systems using both substitution and elimination. And you know what? It's worth saying, right? There are no mistakes, just happy accidents. I made a happy accident, and check it out. It gave me an opportunity to kind of learn.